Now here we're going to study a few different circuits in order to see the differences with one motor and with more than one motor when the circuit is connected either to 120, to 240 or to 480. The first circuit that we see here is with a motor of 1 horsepower producing 1750 RPMs and with a source of 120 volts and 60 hertz. When it is connected to in the low connection, it will require 120 volts, 16 amps, and it will require the multiplication of these two, which is 1920 volt amps. The second drawing is the same motor running at the same RPMs, but now it is connected at 240 volts and 60 hertz. The motor is connected in the high voltage form, and it will require 240 volts, 8 amps, and it will require the same amount of volt amps, which is 1920, just like the 1920 of the first drawing. The only difference between the first and the second drawing is that in the first drawing we were using 120 volts and 16 amps, and in the second we are doubling the voltage, but at the same time we are halving the current to 8 amp instead of 16 amps. Now we go to the third drawing. The third drawing is exactly the same motor with exactly the same RPMs, and we are going to supply now 120 volts, 60 amps, 60 hertz, just like in the first drawing, and we are going to be using a transformer. Now, we are going to be feeding the transformer. It's a 2-to-1 transformer with 120 volts, 16 amps, which gives a total of 1920 volt amps, just like in the previous drawings. And on the other side of the transformer, we are going to get twice the voltage, half the current, but of course the same amount of volt amps like in this first part of the diagram, which is the primary of the transformer. Now, instead of the transformer, we are going to apply our MCUs, which act in a different way than what a transformer would. Now we will be using 120 volts, 8 amps, which means 960 volt amps, and our circuit is going to transform that into 240 volts, which is twice the original voltage, but keeping the current constant at 8 amps. So the volt amps are going to move from 960 to 1920. This is one application of our MCUs as we have defined. Now let's go to a second drawing, second page, where we will have two motors connected in parallel here, which normally will require 120 volts, 32 amps, which is a total of 3840 volt amps, and we are going to use two similar motors of 1 horsepower each, and each will be running at 1750 RPMs. Now, we can do the same, but with a source of 240 volts instead of 120 like before. And what we're going to see is that they are going to be running just like the ones above, but now they are connected to 240 volts. And so we will have to supply them with 240 volts, 16 amps, which is of course half the amount we saw before, and we are going to get the same total of voltamps, which is 3840 voltamps, just like before. Now, in this last part of the drawing, we have the same two motors, but now they are connected in series instead of in parallel as in the above drawings. Here we are going to be supplying them with a source of 480 volts, which gives a requirement of 8 amps instead of 16 amps. Please take into consideration that we are doubling the voltage here, so the current is going to be half of what it was before. But the total of volt amps is always going to be the same. It's going to be 3840. Now we go to the third page, where we have the same two motors in series as before, but now we are supplying them with 240 volts in our source, which requires 16 amps, and this gives us always the same amount of 3840. We make it go through a 1 to 2 transformer, which will turn the 240 volts into 480 volts, but at the same time the 16 amps are going to drop to half in order to have the same number of voltamps, 3840 before and after, as you can see here. When we supply 120 volts instead of 240 volts, we are halving the voltage, so automatically we need to double the current to 32 amps in order to get the same amount of voltamps as above. In this case, the transformer is going to be a 1 to 4 transformer, and the voltage is going to change from 120 to 480. Therefore, the current is going to go down 4 times from 32 amps to 8 amps, so that we get the same value again of 3840 volt amps before and after. Now, instead of putting transformers, we're going to use it with one of our MCUs. Here we place with a source of 120 volts, 8 amps, which gives a total of 960 volt amps, and the output will produce 480 volts, 8 amps, the same current as before. The voltage is 4 times as much as in the input, and the voltamps is also going to be 3840 like before. This is one of the characteristics of these circuits that we manufacture.